Welcome to today's video on Better Together. In this video, I'm going to talk about how to identify relational database workloads that benefit from being paired with AWS Elastic Cache, meaning that when you pair your existing RDBMS workload with AWS Elastic Cache, your workload will have a boost in performance and a reduction in total cost. In other words, the two services together are better for your workload. However, not all workloads are good candidates. In today's video, I will share information about tools and techniques that will help you to identify specific RDBMS workloads that are good candidates to be paired with Elastic Cache. Subsequent videos will focus on other aspects of Better Together, such as caching techniques, modeling and comparing architectures that will result in cost savings and a boost in performance. Hello, my name is Stephen Hans. I'm a Senior Solutions Architect with Amazon AWS. Before we get into the details and the tools and the techniques, first we have to understand the economy of scaling your current relational database. If you look at this graph, on the x-axis we represent the requests per second, and on the y-axis the cost of that. As you can see, early on the curve is fairly flat and shallow, but as the number of requests increases, so will the cost for your relational database. This has to do inherently with the scaling techniques available to your database, which I will get into more detail later on, so you'll see why this curve has the current appearance. Now, what if I were to tell you that we can flatten this curve? We can make it significantly flatter if you were to add a caching service to your existing workload. So this next line represents the cost of requests per second when you pair your workload with AWS Elastic Cache. You can see that it becomes much flatter at the way higher rate of reads per second. In today's video, I will show you tools and techniques that will help you identify workloads that are good candidates to flatten the curve, even find the intersection from which point on to the left or right is your workload located, so that you could have the best advantage by using the two services together. So let's just look at existing scaling techniques of relational databases. Well, practically all architectures look something like this, where you have clients, either straight applications or serverless, depending on what your architecture is, that connect to a database that executes read and write commands. And there's nothing new there. However, in the past few years, we have gotten very good at scaling applications. This is due to microservices and containerized solutions, so applications can scale very easily and dynamically. But when it comes to databases, we only have a couple of options. The first one is scaling vertically. This is when we add a bigger and bigger instance to satisfy the application demands. Now, however, we can only scale up to so far because there's only so much of a bigger instance that we could provide. When we exhaust that, or because of other limitations, we add something called read replicas. Read replicas help you offload read requests from the primary database to multiple read replicas. So the reads are going to happen out of these read replicas. That's what they're called, read replicas. Often this is called scaling out technique. Both of these have been around for some time, well known and used by developers and architects. However, they both have limitations. First of all, as I mentioned, the first one, you can only scale up until so much, and the cost is going to increase double at pretty much every step as you scale up. And the same thing applies at scaling out, even more so because each scaling out database adds a full set of license cost to it and replication overhead, maybe replicating the entire database, storage cost, networking cost, management and maintenance cost. An alternate architecture to this is to introduce a caching service. So the clients still connect to your primary database. They do execute the reads and writes as they did before. However, the reads update the cache, so that what happens that subsequent reads are going to be run out of the cache instead of the database. So you offload the read request to this way faster and cheaper caching service. So what are the advantages of this? Your database remains the same. Even if your workload were to change, the database remains the same. So if you need to scale, you could just scale the caching service. You could scale it up and down dynamically as needed at a much lower cost, much faster rate, and overall better performance. So let's just talk about Elastic Cache. What is Elastic Cache? What it offers? Let's have a quick introduction about Amazon Elastic Cache. Amazon Elastic Cache actually is made up of two separate services. The same service supports two engines. It supports Redis and Memcached. They have different advantages and they're used for different purposes. For example, the Memcached is a strictly based caching service that doesn't offer high availability, but supports a single data type or string data type, and it's very good for that. On the other hand, the Redis-based engine supports 11 data types. In addition to the straight caching service, it's often used for other purpose-built solutions, such as leaderboards or session stores. So they are different, and they have different advantages. The Redis-based engine is way more highly available. It supports multi-AZ and even multi-region replications. Both of these are fully managed services that are available to you. And in fact, as of late last year, 2023, it's also offered in a completely serverless architecture. So in the past, you had to provision hardware for it, a one-time hardware provisioning, and you paid for that hardware whether you used it or not, based on a flat fee. But last year we introduced, and we listened to our clients, we introduced a serverless solution. The serverless solution is very well suited for variable workloads. So if your workload changes in scale, you don't have to scale your caching to it, i.e. acquiring more hardware, because the serverless approach will scale as needed for you. So you just pay for consumption. Both of these are highly available and secure and extremely fast, whether the serverless or the instance-based. They support a number of compliances and they can both scale. So you could scale the instance-based as well, but you would have to manage it yourself. So you have to set up your own thresholds and manage it yourself. So this could end up in over-under provisioning, depending on how you monitor it and how you set up your own auto-scaling. On the other hand, the serverless will scale instantaneously for you as it's needed based on the demand. Let's look at some numbers. What makes up Elastic Cache, why we like it? Well, first of all, it's very fast. You're talking about millisecond response time. And it's not just the open source version of the software. As I mentioned, this has been highly tuned to make it extremely fast and effective on our networks and our hardware offering. They can scale to very large sizes. For example, the instance-based or the provision approach can scale up to 340 terabytes in memory. And the serverless at this point, it scales up to 5 terabytes with more in the future. As I mentioned, they both have been hardened and they support encryption at rest and encryption in transit. And they're very affordable. The instance provision one, it's a flat fee. You pay for the instance size that you feel is your best need with no additional fees. The serverless offering is basically pay per consumption. You pay for as much as you use only. So now that we have some background there, we know about the database scaling and what are its limitations and cost and the advantages that Elastic Cache has to offer. Now let's just see how we can identify what are the workloads that are good candidates for this being paired up. So one of the first approach is to find databases that have high read-to-write ratios, meaning that the higher percentage of the workloads are reads than writes. 70-30 or higher would be ideal. The higher the read ratio, the better candidate the workload is for a caching service. Next is databases with multiple read replicas. It almost explains itself. If you had to add read replicas to your database is doing a lot of read, and you are looking for more read throughput. That's another good candidate for a caching service. Now, not just any workload has to be there. These workloads have to be repetitive workloads, meaning that the same SQL is executed multiple times. Why? Well, if every SQL that you execute is a read one, but they're all different, that means that every one of them has to go to the storage because there's no repetition of it. There's no way to cache that. So they have to be repetitive SQL commands. I will show you how to identify a repetitive SQL commands. And finally, maybe you're at the stage where your workload is just costing too much. Your database charges are just too high, and you're looking at how to adjust that. That curve that I mentioned earlier, perhaps you're way too far to the right end, and the cost has just started to creep up. So one of the alternatives would be to completely rewrite the entire application and migrate it to maybe a NoSQL approach. But that would be costly and very complex. A much simpler approach would be just to add a caching service to it. Your database could still remain as is. You make minor changes to your application to use a caching service. If you're already using read replicas, then your changes are even less because you have already separated the reads and the writes from the database. So now that we understand that, let's just look at some specific methods to identify exact workloads. There are a couple of ways to do that. We could use CloudWatch metrics. We can use database engine specific metrics that we can look at specific databases, how to identify workloads being executed in that specific database kind. If we are on a specific server, such as Oracle or SQL Server, we have some custom solutions that will solve all this for you. You don't have to write any code. And finally, there are some third-party products out there that you can use. So let's just look first at CloudWatch metrics. CloudWatch metrics, if you're already in AWS Cloud, are available to you, and you can use those metrics to find out what's the read-to-write ratio on your database. Easy way to find out because you can see how much data goes in and out. That may not be sufficient just to find out how much data goes in and out, and may not be something that you like to do to CloudWatch, or you have multiple kinds of databases. So for that, we have developed a new product called dbTop Monitoring Solution. dbTop is a multi-platform monitoring tool that can help you monitor various database aspects, such as number of transactions per second, read-to-write ratio, number of megabytes going in and out of your database. In this case, is actually a screenshot of monitoring Elasticache, but it can monitor MySQL, SQL Server databases, RDS as well. So now that we have some high-level understanding, you want to go into the more details to find out what exactly is happening in your database, what kind of SQL commands. For this, you'll have to look at various specific SQL engines. So for example, if you're using a SQL Server, then you have to look at the exact query stats table. You would have to select from that table to see the exact kind and the number of times the SQL is being executed. And I will give you a very detailed example for this platform. For other platforms, you'll have to probably do something similar, a little research yourself. For Oracle, you would have to look in VSQL table. If you're already in Amazon RDS, then you can use Performance Insight to find out how many times the same query had been executed, basically calls requests per second. If you're on MySQL, you have to enable general log to a table and query from there. And if you're on Postgres, then you just have to select from pgstat statements table. You will find the information in there about the number of times the SQL has been executed and the nature of the work that it has done, as in ratio of read to write. So as I mentioned earlier, here is an example from a SQL Server. In this case, the SQL Server is being queried, and this query is easily, readily available on many websites to find out what SQL is being executed. But the output is more important than the columns that we are looking at. It's more important. You have to select the execution count to find out how many times the same SQL is being executed or re-executed, and the total and the average reads. This is going to tell you how much the SQL is reading on average and in total, or in writing if it does no writing. So in this case, the top SQL had been executed more than 100,000 times and is doing a lot of reading. So definitely way more reading to writing. So this is a good example. You will have to write the query something similar to this for the other RDBMS engines. However, if you're on Oracle, we have a specialized tool that was developed just for Oracle. This tool had been around for some time. It's called DB Current State Investigation, or DBCSI. This tool had been around that you could download and run it on your existing workload, and it helped you with migration from on-prem to the cloud of your Oracle database. The product had been upgraded so that now it looks at the past workload, the kind of work that it has done, and is going to recommend that if the workload is such that it's a good candidate to be used with the caching service, it is going to make two recommendations, one without and one with the caching service. It will calculate the different instance types that you would need without and with the cache. Even it will try to recommend the cache size and calculate potential monthly savings for you. So you don't have to write any code if you're on Oracle. The same thing could apply to SQL Server. The tool RDS tools have been around for some time, and it always helps you to right size your database, to find the right size instance if you're underutilized, if you're over basically your capacity. Then RDS tools help you with that. Now RDS tools have been upgraded for Microsoft SQL Server, and now it is going to help to look at the workload and look at the read-write ratios and the queries, and will try to recommend that if the workload is such, it will recommend that you should use a caching service for your workload. So in a recap, just to understand it better, adding a caching service to your database will help you with your throughput because AWS Elasticache is very fast. It will reduce your application overall response time. All the data is going to be cached in memory at all times. And you can offload all those repetitive IOs from the database at the way lower cost than scaling your database. Here are some QR codes to follow up on the products that we talked about, the blog that goes into a lot more details and cost calculation and performance comparison. Learn more about the Elasticache. And finally, here are QR codes about the various tools that I mentioned. DB Top Monitoring, DBCSI, and product for Microsoft SQL Server RDS tools. If you'd like to learn more, here's some contact information, how to reach out to me or to our team. Thank you.